Okay, so today for part of your e-learning assignment, you're going to read through the top of this next chapter called Inequalities, and then you are going to fill out your chapter goals. So before the chapter starts, just like we did prior to equations, you are going to fill out the topics you think you understand, the topics you think you need to review, maybe some topics you've never worked with, and the overall chapter goal. The vocabulary is pretty short this chapter and listed below, and then we're going to get started with this review lesson. So what is an inequality? Well, an inequality is defined as, kind of up here we have some inequality symbols and solutions to inequalities. So it is a range of numbers that make a statement true. What do the following inequality symbols mean? So if it points to the left, we know that it means less than. The next one is still less than, but it also has the equal to or equal to sign, so less than or equal to. Points to the right, it means greater than. And then, of course, with the half equal sign, greater than or equal to. Moving on, which inequality symbol would you use? So just with these word phrases, we want to be sure that we know which inequality symbol to use. So on the left-hand side here, we have no more than, which means it's going to be the less than symbol. Of course, then there's less than. A minimum means if it's a minimum number of 5, everything has to be greater than that 5. And then if it's a maximum of 5, everything has to be less than that 5. These are also going to get those equal to, because if that minimum is 5, it can be 5 or below, or the maximum is 5, it can be 5 or less. At least, it means it has to be at least 5, so that would mean it could be greater than 5, but it could also be equal 5, or at most, opposite, less than or equal to. More than and fewer than are pretty easy with greater than or less than. Write an inequality for the following scenarios. So you could do a few things here. You could pause this video, do these 12, see if you're on the right track, and then listen to it back and see if you got them correct, or you could follow along as I go through them. So number 1, the car riders have to be at least 4 feet tall to ride the roller coaster. So I'm going to use R for riders. If they have to be 4 feet tall, they have to be at least equal to 4 feet or greater than 4 feet, and they can ride the ride. So then we're going to put 4 feet. I'm going to go down the left-hand column. Katie has no more than $10 to spend at the mall. So I'm going to use K for Katie. I know I have $10 and she cannot spend any more than 10, so less than or equal to the exact amount of $10. James J had fewer than 6 baskets, so he had less than 6 baskets. Hannah's backpack weighed less than 15 pounds. I'm going to use H for Hannah. Her backpack is less than 15, and I'm going to abbreviate pounds with LBS. Tyler has 8 friends at most, so T for Tyler. If he has 8 friends, he can have equal to 8, but if he has at most, that means he's going to have less than or equal to 8 friends. Each class has to meet a minimum of 3 times per week. So C for class. The minimum means they can meet exactly 3 times, but they could equal more than 3 times, but not less. Going to the right side, Jacob wants at least $200 in his bank account by the end of summer. So J for Jacob, we has $200. He could equal $200, or he could do at greater than. A healthy baby weighs at least 6 pounds, so we want them to be equal to 6 pounds, or they could be greater than. George weighs more than 65 pounds, so G is greater than 65 pounds. The cost of the purse P cannot be greater than 55, meaning it could be exactly equal to 55, or it needs to be less than $55. Stuart wants to work a maximum of 20 hours a day, so S for Stuart. He doesn't want to equal more than 20, so less than, but he could work exactly 20 hours. And then Katie K can spend up to $240 on her back-to-school shopping spree. So she can't spend more than she has, so less than or equal to $240. So there are your inequality scenarios. Let's go over reviewing and rewriting inequalities. So the X is first. So why do we write the X first? And this has to do completely with graphing later on. So all we're going to do when we write the X first is we're going to flip the X and the number. And then because that flips spaces, we're going to point the arrow in the opposite direction. So this arrow here pointed to the right, so I turned it around and pointed it to the left. Switch the variable and the number, and then flip your sign around. Make sure that still gets that half equal sign. Flip it around this way, open to the left instead of open to the right. X is less than 0, and X is greater than negative 15 3/10. So everything, that variable is going to end up on the left side of your number, and you have to switch your sign over. How would you describe the solution of an inequality? So if I use the example X is less than 3, the numbers that would work to make that statement true are numbers less than 3. So 2 is less than 3, that works. 1 is less than 3. In fact, negative 1 is less than 3. So because all of those number scenarios work, we can say that solutions to inequalities have many answers. And in this last section, is each number a solution, right? Yes or no? You have to check each of the multiple choice items by putting them in for the variable first. So you're substituting in for X, and then you're asking if the statement is true. Is 9 less than 7? No. Is negative 1 less than 7? Yes. Is 7 less than or equal to 7? Yes. Is 0 less than 7? So you should have circled B, C, and D. If you want to pause and do the next couple, you can try them on your own. I'll go on to number 7. So I like to write them all into the inequality first, and then ask if they're true or false. So negative 4.1 is equal to negative 4.1. Negative 5 greater? No. Negative 3 greater than negative 4.1? Yes. And 0 is also greater. Notice in number 8, you have a special scenario here. You need to flip around first, then ask true and false statements. So this statement is true. Negative 2 is not greater than, it is greater than negative 5. 9 is greater than negative 5, and negative 5 is actually equal to, so this one is the only one that does not work. And then last, we have 9 and 10. both need flipped. So we'll start with number 9. And of course, you don't have to write these, but sometimes it just helps to visualize the numbers. So this one is -9 is less than -6.2. 0 is not less than -6.2, so that is out. -6.2 is equal to -6.2, so circle. And -1 is not less than -6.2, so that one also gets crossed out. Last one, you do want to flip this around even with the numeral 0. So 5 is greater than 0, yes. 0 is equal to 0. -3 is not greater than 0. And -2 is also not greater than 0. All right, that should wrap up kind of getting into review mode with inequalities, and you should be ready to move on to lesson 1 tomorrow.